All right, here is the highly touted homework help video, usually the most views of any of the videos I make. So today we're going to go over problems 2, 4, 9, and 13 from the practice sheet. Two of them are just finding reference angles, and then the other two, 9 and 13, are finding the exact trig values. So let's sketch these angles and find the reference angles first. All right, let me switch over to black. So we get 285 degrees. So to sketch the angle, right, you're going to find your vertex and you're going to do your initial side. That's always the start. And we can actually do that on the other one as well because it's not going to be any different. And then we're going to figure out, okay, how many quadrants are we going to go through before we got to like be more exact? Well, you're going to go 90 degrees here, another 90 gives you 180, another 90 gives you 270, and we want to go to 285, so we're going to go another additional 15 degrees past that y-axis. So we're going to go about right here. And then here is your main angle, right? So this is the 285. And so the reference angle we want to find is going to be the angle between this final side, right, the terminal side, and my x-axis, which is right up here. So that's my theta prime, and that's going to be equal to, well, all I got to do to figure this out is just do 360 minus 285, and then that's going to give me my reference angle, which is going to be 5 and 7. So if it was just another 15 degrees, right? Well, 15 plus 75 is 90, so that kind of makes sense, right, with what we just figured out. And there you go. Your reference angle is 75 degrees. All right, so for number 4, we are going to, first of all, convert to degrees because we have 7 pi over 4 radians. So we know that there are pi radians. We put that on the bottom, so it will cancel for every 180 degrees. So your pi's will cancel and your radians will cancel. And then let's cross off any stuff we can cross off. So 4 goes into 180 45 times. And I know that because I've done enough of these problems and seen that. And then we just got to figure out what 45 times 4 is, or times 7. So 45 times 7 is going to give me 5, and then you add 3 to that, it's going to give you 315 degrees. So I have another angle that's actually going to be in my 4th quadrant, because we know this is 270 from the last problem. So if I subtract 270 from this, this is going to give me the remainder of how far I got to go. So I got to go an additional 45 degrees, right? So that's going to split it right in half. So we're going to go there. I know this is 45. My entire angle can be marked like that. And you have 7 pi over 4 radians. And so now my reference angle is going to be this angle right here. Okay, and that's my theta prime. And we knew this was 45 degrees right here. Well, that means that this has to be 45 degrees because 90 minus 45 is another 45. And if that's confusing to you, then just do the 360 minus 315, and that will also get you to your 45 degrees. So your reference angle is 45 degrees. All right, so now let's do the problem 9 and problem 13. So we're going to kind of do what we just did, but then we're going to take it a step further and find the trig values. So the cosine of 150 degrees, let's find 150 first, right? So 150 is going to be 90 and then an additional 60, right? Additional 60 degrees. So this is my 150. So in order to find the cosine of that, I got to find the reference angle. So my reference angle is right here. Well, if I'm going 150 degrees and I know it's 180 to get over here and I just want this little angle, I just go 180 minus 150 and that gives me 30 degrees. There is your reference angle. So that is the angle you will use to find the cosine of. So let's go to our chart. So the cosine of 30 degrees is equal to the square root of 3 over 2. So let's write that down, square root of 3 over 2. And now all I have to do to finish this up to find out what the cosine of 150 degrees is find out, is my sine staying the same or changing because of the fact that I'm in the 2nd quadrant, not the 1st. So the second quadrant for cosine tells me that it does in fact change and it becomes negative. So the only difference is you will write the same number, you're just going to make it negative. So it will be negative square root of 3 over 2, and that is that for that one. All right, and then for this last one, all right, last problem, we are going to figure out degrees, first of all. So we have 5 pi over 4 radians. So you're going to multiply by your converter, which is pi radians. That will be on the bottom to cancel out. You'll find those all kind of set up the same. And then times 180 degrees. Well, 4 goes into 180. Apologize for that interruption. So 4 goes into 180 45 times, which we actually did in one of the last videos. And you'll find you do a lot of these same division problems on these, right? So 45 times 5 is going to give you 5, and then 2, so 225 degrees, right? And so 225 degrees is 45 degrees more than 180, right? So you go 90, 80, and then 225 minus 180 gives you 45 degrees. And the benefit of this is now we kind of know where it is, but we also can know that that's going to be a reference angle because we were relating it to the x-axis here. So that's 45 degrees, my reference angle. So I'm going to find the cotangent now of 45 degrees. And that, my friends, is 1. All right. So that equals 1. So in order to find my final answer, which is the cotangent of 5 pi over 4, you would look up where we're at with cotangents in quadrant 3. So this is the quadrant we're in. So in quadrant 3, we are, for cotangent, keeping it positive, right? So it would just be equal to 1, and you didn't have to really change anything, and away you go. So good luck with these. Don't overthink them. Just find that reference angle. These you can use a lot of common sense with these, and then just reference your chart for your values and for your signs. So good luck, and we'll see you in the next one.